Hello, my name is Harshan. This is my physics lab on tape charges. Now, the introduction. So, the purpose was to use tape in order to observe the transfer of electrons between surfaces and to calculate an estimate of the number of charge of electrons transferred. Now, the fundamentals. So, using tape helped me model point charges by assuming each piece of tape had an equal distributed charge in order to apply Coulomb's law. I was able to use Newton's second law and Coulomb's law to calculate the charge on each piece of tape. I then Googled the approximate dimensions of an atom to calculate the number of excess/deficit electrons per atom on a piece of charged tape. Now, the results. So each piece of tape repulsed each other. Charged pieces of tape repulsed each other. Charged pieces of tape were determined to be positively charged. The charge on each tape determined to be in the range of 1.02 times 10 to the negative 8 to around 1.34 times 10 to the negative 8. Now, each piece of tape was determined to be deficit of about 9 times 10 to the 10th electrons. Now, my model was each tape represented a point charge to observe interactions for the transfer of electrons. Now, the assumptions were air resistance is negligible, treating a long piece of tape as though if it was a point charge with all charge concentrated at the center of the long tape, and assuming that each U tape had about the same amount of charge evenly distributed along the length of the tape. Now, the experiment. So the system was tape A and B and all other external forces. The initial conditions were two pieces of approximately neutral tape, also being about equal in length, and a third piece of neutral tape stuck down on my desk. Now, the details were tape B was stuck to the tape on the desk and ripped off quickly in order to charge it, leaving behind electrons through the process. The tape was then hung near several objects to determine its charge. It was finally placed above the other piece of similarly charged tape A, until a portion of it floated and the distance was measured between the tape to calculate its charge. Now, these were a couple of my observations. So, the U tape was attracted to my bed. The U tape was repelled by another piece of U tape. The U tape was attracted to a neutral book. And finally, the U tape was attracted to a negatively charged pencil. The conclusion was the tape was positively charged and had lost electrons in the charging process. Now, these are my data and calculations on the screen. So we got tape mass is 0.001 kilograms, tape length is 0.24 meters, tape width is 0.021 meters, and the distance between the two pieces of tape was about 0.027 meters. And calculating the force of gravity, I just used Newton's second law, F equals ma, and I was able to calculate that. Now, this is my glow square model. On the right shows my code and how I was able to get these calculations that's shown on the left, and on the left is actually my model of my prediction model, and also the charge of like my tape and all that. Now, my discussion was, so in the discussion we have model discrepancies. Now, the discrepancies were no true point charge, and charges on the tape are not exactly equal, and sources of error where unequal charges on the tape may not have been the same for each, and some charge may have been lost on the tape due to handling it. Now, what if electrons have positive charge and protons have negative charge? What would change about the observations you made with your tape and other charged objects? So, if electrons had positive charge and protons had negative charge, the direction of electric forces and fields would reverse, but the magnitude of the forces and behavior of charged tapes would remain the same. This is because interactions depend on the relative charges and not their signs. Now, why is it important to handle charged tapes as little as possible? And what happens when the charged tape comes in contact with your hands or other objects? So, handle the tape as little as possible to avoid losing or neutralizing charge. When tapes come in contact with your hands and other objects, the charge can transfer to them, reducing the tape's charge, making measurements less accurate. Now, the conclusion was everyday objects can be used to model point charges and observe electric interactions by charging them. Newton's laws of forces can play an important role in determining individual qualities associated with an object. Objects can easily and accidentally be slightly charged through touch alone. And finally, electrical forces and fields are an important part of our world that account for many physical interactions that occur. Thank you for listening.